All right, looks like we're live. Hello everyone and welcome to another Zodin session. Happy New Year everyone, by the way. It's the first stream of 2022, right? So it's 2022 now. And let's make a little bit of an announcement and start this stream. Hello Lanilo, hello Okras, hello, Happy New Year to you too. Thank you, welcome. So, Red Circle live on Twitch. And what are we doing today? We are parsing PNG in PRC. That's literally what we're doing today. That's the topic of today's stream, believe it or not. Okay, so let me see. So the question is, why the fuck would I even do that? But here is the thing. I wanted to learn the PNG format for quite some time because I wanted to understand it. And I heard that the format itself actually allows you to maybe hide some data within it, right? So you can have an image and also, you know, some data that is along the image, but the viewers can't see that. And I thought that I want to learn that format and understand how you can do this kind of stuff. So today I'm gonna just like explore the PNG specification. I'm gonna write some C code. I'm probably gonna use some libraries, but I'm not gonna be using any PNG parsing specific libraries, if you know what I mean, right? So essentially I'm gonna use libraries that maybe give me some data structures, right? So hash tables or maybe dynamic arrays, and maybe use some libraries that can perform the deflate algorithm, right? So they're not particularly PNG specific, but PNG uses deflate algorithm for compressing the data, so we might use that. We're gonna like look at the structure of the PNG format without going into too much of a rat hole. And that's what I wanted to do today, just explore the PNG format, because I think it's fun. It is fun to explore such a ubiquitous image format that is everywhere and understand how it works from the inside. I think it's kind of cool. So hello everyone, welcome. How are you guys doing? Happy New Year. So to start, we need to, you know, have some sort of a PNG specification. Luckily it is on the official website. It exists on the official website, so we can Google up PNG spec, and I think this is the first thing that will pop up almost. PNG format specification. So there is one on W3, there is one on lippng.org. I think this is the one that I'm looking for. So yeah, here it is. I'm gonna give the link in the description for anyone who's interested, and also in the chat. So PNG specification of our nation. Oh, okay. So, and I think the thing that we're interested in is basically the file structure, right? So it's that one. There's also a bunch of stuff like related to integer byte order. As far as I know, PNG uses the big endian one, right? So that's something that we have to be aware of. So let's actually go ahead and start coding, I think. So coding, and let's create a folder called PNG, and we're going to be using a PRC for that because it's a very simple language, so nothing is going to distract us from parsing PNG. None of the fancy features of the language, none of the monads, none of the traits. It's just like a very dumb, simple language, and yeah, it will help us to stay focused on our goal of exploring the PNG format, right? So, and that's precisely what we're doing today. We're not exploring any other format. We're exploring specifically PNG today. So let's create main.c, and we're going to include std.io and also create an entry point. So, and we're going to write a hello world just to test that our compiler still works after so many years. Like the last time I checked when my C compiler works was last year. Anyway, so let's try to compile this thing. Main.c. So maybe I actually want to call it something like PNG, right? And gcc o png.c. And if I try to run this entire thing, it says hello world, as you can see. So maybe we want to have some sort of like make file or build file. Yes, we want to have a build file. So I'm gonna do build.sh. Bin sh, and in here I'm gonna just like, you know, set xe, set tracing, set the errors, and I'm gonna just do cc. This is not how we do that in shell. C flags, o png, png.c, and we're not gonna link with any of the libraries yet. But we're going to set the compiler to cc and flags to wo and w extra. So Vincent Hawks subscribed with 2 months of tier 1 subscription, saying, hey yo, thank you so much for 2 months of Twitch Prime subscription. Thank you. And welcome to our epic PNG club. How about that? Anyway, so there we go. Let me see if we can even run this entire thing. So I'm gonna make it executable. And there is no such thing as extra, apparently. And this is because I think I have to wrap this entire thing in quotes, because bash, right? And there we go. So now we have everything compiled. Isn't that beautiful? I think it's freaking beautiful. So the first thing I want to do, I want to be able to maybe accept the file path to the image that we're going to be parsing and exploring. So the first thing we need to do here is just accept argc, argv. So I prefer to parse my entire arguments using only argv. I quite rarely use argc these days, and the reason is because I recently discovered that argv, according to POSIX standards, always ends with null, which makes it kind of easier to parse, right? Essentially, you can just, you know, grab the first argument that you have in here and then increment it, and if you ran out of arguments, the argv is going to be just null. Right, so essentially you can treat argv as a stack, and you popping out the arguments out of the stack until it becomes empty. And quite frankly, you just don't need argc anymore, because you always know the end of argv. It just like simplifies everything. So yeah, but here's an interesting thing. So usually the first argument is a program, but nothing in the type system of C actually guarantees us that. So we want to make some sort of assertion saying that if we want to have a program, so we want to make sure that this thing is not null. Otherwise, this entire thing is going to be null, and it's kind of like, you know, not true. So there we go. Now let me see. Okay, so if I go to actually do some things in here, and the next thing, if argv is equal to null, right? If it's equal to null, that means we don't have any arguments, right? We don't have any arguments, and I'm gonna say that. So this is gonna be usage, and in here I'm gonna be just using the program. Input PNG, right? So this is the input PNG, and this is the program. Right, and then I probably want to do that in the standard error, right? So this is going to be the standard error. And the error is going to be no input file is provided, right? No input file is provided. Program, and then we're going to exit with non-zero exit code. If the file was provided, we're going to say that the inspected file is, and we're going to just print I suppose something like this, right? So this is going to be input file path argv++. Input file path. Okay, so let's try to compile the entire thing. And okay, so we don't have an assert. Let's include assert very quick. So error, what does it say? Too many arguments. Yeah, I don't know why I provided the program in here. Okay, so there's also exit, and that means I need to include the stdlib, right? I need to include the stdlib, and I don't need argc, at least right now. Maybe in the future I'm gonna need that, but we'll see, all right, so if I try to run PNG now, as you can see, yeah, I'm an idiot. So it's the other way around. My brain thought the other way around. Let's try to recompile the entire thing. So it's going to be build sh, and there we go, no file was provided. But if I provide some file like hello PNG, it says that inspected file is hello PNG. We have a very simple program that just accepts the argument and just checks whether user provided that argument or not, and reports error and whatnot. Anyway, so we need some file that we want to experiment with, right? So let's go to PNG format, maybe Wikipedia page. And let's grab something from there. I think there is like a, you know, this thing. Let me see. So I'm gonna basically download this thing here. So I wonder what's the license of that image. Does it even say any license? I'm not quite sure. I can't see shit in this mist. So CC by SA, so... share alike unported. I have no idea what that means. Copy or distribute the material in any video format. A remix, transform and build upon material for any purpose. The license cannot revoke these freedoms as long as you follow the license. You have to give the attribution. Right, share alike if you remix. Okay, I see. So maybe essentially I'm gonna just like put this thing in the description for now, and I should not forget to maybe add that to readme. So test image was taken from here, right? So it's that one from the Wikipedia, and let's go. So we've got a sub from Gordon Nerd. Thank you so much for Twitch Prime subscription. Thank you. Your first subscription, by the way, and welcome to our epic PNG club. How about that? Kami SMB, thank you so much for 2 months of tier 1 subscription. Thank you, and welcome to our PNG club. Another, there's so many subs today. Thank you, Nizik, for Twitch Prime subscription, your first subscription as well, and welcome to our epic PNG club. Thank you, everyone. Okay. All right. So let me see what we have to do next. I suppose the next thing we have to do is basically open the file, right? So I'm gonna just open it with fopen, input file path, right? Then I'm gonna read it as a binary, right? So that's the thing we want to do in here. And I'm gonna call this input file, right? And if input file, not file path, but file, is null, we have to report an error. The Busy, thank you so much for tier 1 subscription, your first subscription, by the way, and welcome to our epic C club. So in here we're gonna just print, do we need to print the usage? I don't think so. We're gonna just print the error, could not open file this because of this, right? Input file path, str error null. There we go. So, and I suppose we also need to include string and the error no module, right? So let me see. Could not open file hello PNG. Okay, that makes a lot of sense, but I think I also forgot to put a new line at the end of this error message. I think this is a very important thing. Okay, so as you can see, we don't have a hello.png. But now if I provide the PNG transparency demonstration, everything works fine, but also at the end, I think we should just basically close that file. We should close that file. What's funny is that closing the file can fail, right? But does anyone who closed the file ever cares about the failure of fclose? Because this one is kind of interesting. So if I remember correctly, so it can fail because of the file descriptor underlined stream, and oh yeah, because it can also flush and stuff like that. Yeah, so it may fail because flush failed, because write failed for whatever reason, right? Maybe it can happen with the network, right? So, but it can probably also happen with the hard drive, who knows? In any case, usually we don't care, and I wonder, do I want to handle that? Probably not. Anyway, we open the file and we can now read it. So let's take a look at what we can read within that file. I think that is very, very interesting. So a PNG file consists of a PNG signature followed by a series of chunks. Okay, so PNG is basically a format that consists of chunks, right? Very interesting. This chapter defines a signature and the basic properties of chunks, individual chunk types, and are discussed in the next chapter. Okay, so this is precisely what I wanted. I wanted to just explore the structure of the PNG, and the structure is basically a sequence of chunks, if I understand correctly. And then once we understand that, we can go deeper into different kind of chunks, I suppose. Right, so, but at a high level, it's just basically chunks. The first 8 bytes of a PNG file always contain the following decimal values, and here are the values. This signature indicates that the remainder of the file contains a single PNG image consisting of series of chunks beginning with an IHDR chunk and ending with IEND chunk. Oh, it's probably IHeader and IEND. Okay, so there's a header chunk and there's end chunk, which is rather interesting. So if it's just a sequence of chunks, if I understand correctly, can I just put some shit after the end of the chunk and the viewers will ignore that because they may ignore the end chunk? I don't know, we'll see. So let's actually try to read the signature, right? It's supposed to be 8 bytes, right? So let's allocate 8 bytes on the stack. So we're gonna have something like maybe uint8 signature 8 bytes. So for this thing to work, we probably need stdint, right? So because in stdint we have definitions for uint8 and some other stuff. Fread. So this is how we're gonna be reading the bytes. Okay. So here's an interesting thing. We provide the signature. So size is the size of a single element that we're trying to read. You can basically say that the size of a single element here is 1, meaning that it's a 1 byte, and the amount of elements you want to read is 8. But you can go the other way around. You can say that the size of the element is 8, and the amount of such elements you want to read is 1. So essentially, by doing that, you're indicating that you're reading one buffer of the size 8. Which is also correct, right? So, and I think I want to go with that, and I can also give the size of this entire thing. And we're reading that from the input file. So what's interesting is that if everything went correctly, right? If everything went correctly, fn is going to be equal to 1, indicating that we read one buffer. If it was not equal to 1, I think something went wrong. But here is the interesting thing. fread returns size t, which is unsigned, so the error is not really indicated by a negative value as it usually is with POSIX functions, right? So the error is indicated by ferror, right? So basically, if error has happened, the function sets the error flag. If there was no error and we just reach the end of file, it just sets the end of file flag, right? So, and you have to kind of distinguish between those. So, and this is probably what we have to do. So if the amount of buffers that were read was not equal to 1, we have to check whether it's an error or an end of file. In either case, we don't really want that, right? Because we're expecting at least 8 bytes. Even in case of end of file, we want to throw some sort of error saying that, bruh, you probably have an incorrect PNG file, right? Because it doesn't have the expected header. Right. So if we encountered an error, what we have to say? We probably have to say that we couldn't read shit from this mist. So error could not read to PNG header because of this specific reason, right? And the reason can be taken from the error null. Right. So the reason is taken from error null, and then we exit with non-zero exit code. There we go. Otherwise, if we reached the end of file, right? We reached the end of file. We probably want to say something similar. I think we want to say something similar, like could not read PNG header, reached the end of file. Right, so this is also the special case that we have to handle. Otherwise, I think this is an unreachable state. Right, if we didn't read a single buffer, right, and no error was encountered and no end of file was encountered, it's kind of like a, you know, unreachable situation. So we want to look out for those. So we're going to do an assert saying that this thing is unreachable, right? So this thing is unreachable. So yeah, there we go. So and after that we probably want to print the buffer that we've got. So let me see, I'm gonna just do for size I less than size of signature plus I, and essentially what we're gonna do, we're gonna just print u signature I. There we go. And at the end of this entire thing, we probably want to just set a new line. So let's take a look at this entire stuff. And there we go. This is what we've got. Right. Is it equal to whatever we have in the specification? Apparently it is. So this is basically the expected signature. How about that? So how's it going, everyone? How's it going? Writing root error messages for unreachable points is my favorite thing. I don't think writing root error messages in software in 2022 is a good idea, to be fair. 2022 is not the same as, you know, 20, 30 years ago, so like generally you probably want to be nice in your software. So I'm not really interested in steganography today, right? So I know that you can do some steganography and it could be an interesting topic for another day. The topic of today is specifically exploring the PNG format, right? So that's like literally the goal. Let's explore the PNG format. I know that you can have a format agnostic ways of hiding information within the images, and that's what steganography is. And it is an interesting topic, but it's not the topic of today. You can even place a couple images inside of a single file. That's how APNG works. That's very interesting. Yeah, you technically can, right? So because you have a bunch of like chunks and stuff like that, it's just like, why not have several sequences of chunks that represent several images? And also you can probably have a chunk that has meta information on how to play that animation and stuff like that. So all right, so the next thing, I think we're going to be reading a fixed size buffer quite often. So I think I want to abstract this thing away into a separate function. So we have a couple of more subscriptions. Thank you so much, 42QA. I hope I'm pronouncing the name correctly. Thank you. And welcome back to Epic PNG Club. And policy changes cheered with 1,000 bitcoins. Holy fucking shit. So plain C hype says policy changes. Thank you so much for so many bitcoins. I really appreciate that. Alrighty, that's very cool. So let's abstract this thing away. I want to have a function that just basically reads the buffer and then panics if it couldn't read the buffer. You know what I mean? So I think that's basically what I want to do. Basically read a buffer or panic. It's going to accept the file it's reading and then it's going to accept the buffer. And also the buffer size. So it's a buffer size or maybe buffer capacity. Does it need to accept anything else? I don't think so. I think it's fine for now. And what we want to do in here is just copy paste this entire thing into read buffer or panic. So Akileo77, thank you so much for tier 1 subscription. Thank you, and welcome back to our Epic C Club. So Yesu, thank you so much. Okay. So if I try to compile that, so I'll definitely need to rename some of the variables in here and stuff, but I want to let the compiler tell me what I have to do. Okay, so sig has to be replaced with buffer. Right, it's not a signature, it's a buffer now, and the size of the buffer is actually represented by the buffer capacity. So this is how essentially we're gonna do. Input file has to be replaced with just file, I presume. Maybe we're gonna just call it file. Query replace input file. There we go. Cool. And that's basically it. That's pretty cool. So, and now instead of this kind of stuff, I can do read file, read buffer or panic. I provide signature, size of signature, and first thing I have to provide the input file. There we go. So, and I can just like remove this entire thing, and I don't have to copy paste this entire stuff like every time I want to read like buffer with fixed size. Right. So, and another thing I want to have is probably print the bytes, right? So maybe we're gonna use this kind of thing quite often, and I want to be able to just print some bytes just to inspect them. So let's do it the following way. We're gonna have print bytes, and it will accept essentially this thing. So it's almost like a slice in Rust, right? In Rust, when you pass a slice, you're actually passing one value, but under the hood, it's in fact two values, pointer plus its size. It's just like in C, you're being more explicit with that. But yeah, so passing like a pointer and the size is like passing a slice in Rust, but explicitly. So let's go into the print bytes, and I'm gonna copy paste this in here, and I suppose I'm gonna do it like that. I'm just gonna copy paste this stuff. I'm gonna query replace sig with buff, and size of buffer has to be buff capacity. So now what I can do is just allocate some buffer on the stack, read stuff into that buffer, and just print the bytes of that buffer. There we go. So it's pretty convenient. So another thing I would like to have is probably like verify that we're reading a correct PNG image, right? So and we can do that by comparing the signatures. So let's take this thing and wrap it into like a global array of some sort. PNG signature, right? So this is a PNG signature. And here I can replace spaces with commas. Kokokov, thank you so much for Twitch Prime subscription, your first subscription, by the way, and welcome to our Epic C Club. How about that? Bet you didn't expect that shit to happen. Anyway, so we can probably even have some sort of like a, you know, global variable that says the size of the PNG signature, PNG signature capacity, right? It's 8. PNG signature capacity, and that way I can even now do the following thing: PNG signature capacity. And after that, we can just compare two signatures, right? If memcmp, we're gonna use a function memcmp. I think it's a good idea to do something like that. It just accepts two buffers and the size and just compares them. We know that the buffers have the same size, so we don't have to worry too much about that. Right, so we have the signature and we have the PNG signature. And the size of this entire thing is the PNG signature capacity. And if this thing is not equal to 0, that means these are different things. So, and let's report an error. We can say something like file does not appear to be a valid PNG image. There we go. And then we're going to exit with one exit code. So then we can say something like printf is a valid PNG image. And we can provide file input file path and I forgot to put an input file path in here as well. Input file path, like so, and I don't know why I put this stuff in here, and let's recompile everything. Define. Okay, so this thing is in fact a valid PNG image. It is a valid PNG image. If I try to, for instance, give it the source code of itself, right? Wait, what? Okay, there we go. It will say that png.c does not appear to be a valid PNG image, right? So it sees these first 8 bytes, and this is not a PNG signature, so it's not a valid PNG file. So that's pretty cool, I think. I think that's pretty cool. So let's actually commit everything in here and upload to some sort of like a repo and share with everyone, because we already have something, you know, shareable, I think. We have a very simple program that verifies that a file that you provided is a valid PNG file. How about that? I think that's pretty cool. Buffer or panic, thank you so much. So I have a little bit of a performance anxiety right now, so that's why I'm like making a lot of typos. I'm very sorry. All right, so let's do a committee and maybe even a push. So this is going to be git ignore, and we want to ignore PNG. I don't really want to ignore this file. I want to keep it in here, right? So, and I'm going to do git init. So I think I'm going to do a readme. PNG file format exploration. We're going to have a quick start, and in a quick start, we're going to say build.sh, then PNG, and inside of the PNG just provide this file and just see what it will tell you. And we're also going to have some references, and the references are primarily the specification. I may actually take the references from here. Yeah, so I think that should be enough. And for the license, we're going to use MIT. All right. Ready, set, go. And if I remember correctly, I can just like add the remote here. Git at gitlab.com, sodding png.git. Fuck, it's a remote name. Add origin, git at gitlab.com, sodding png.git. Yeah, make it default. It's gonna take some time, and I'm gonna try to push that right into the repo. Okay, so it seems to be created now, I presume, but it's private, right? It is private, so I need to now make it public. So why is it so weird and slow? Visibility, and this thing has to be public. Where do I save everything? I save everything in here. Okay, so if you're interested, you can find the source code of this entire thing in here. Yeah, GitLab apparently lets you create project without going to the website. Wasn't it you who told me that? I don't remember. Okay, so I'm gonna put that thing in the description as well. So source code, there we go. So here is this source code. So we verified the signature. So what's going to be the next thing? Chunk layout. Each chunk consists of 4 parts. A 4-byte unsigned integer given the number of bytes in the chunk data field. The length counts only the data field, not itself. The chunk type code, not itself, the chunk type code or CRC. Okay, so here is the chunk type, chunk data, and CRC, cyclic redundancy check. Okay, so basically there is some sort of like a, you know, sum check for the data or something like that. I kind of remember, I think there's even an algorithm given to you in here which we can copy paste later. But yeah, that's pretty straightforward. And also, if I remember correctly, all of the numbers are big endian numbers, so we have to be aware of that. Integer and byte order. All of the integers that require more than 1 byte must be in network byte order. The most significant byte comes first, and then the less significant bytes in the descending order of the significance. MSB, LSB for 2-byte integers, blah blah blah. The highest bit value 128 of a byte is numbered bit 7. Okay, I see. So yeah, essentially what we can do, we can try to read buffer or panic, and let's allocate uint32 chunk size. Right, so this is our chunk size. So this is going to be chunk size, and we're reading the size of that 32-bit integer, and we have to provide actually input file. So, and after that we can try to print the chunk size, right? And we'll see that it's not particularly correct. I think it must be incorrect. So I think we have to do something like u chunk sz. Let's call it chunk size. So passing argument to of read buffer from incompatible pointer. Oh yeah. So in C, well, you can actually basically assign any pointer type to any pointer type. But if you enable a lot of warnings in GCC, you can't just assign any pointer type to any pointer type, but you can assign any pointer type to void pointer and any void to any type. So through a void, you're kind of indicating that you don't really care about specific type, you're going to reinterpret it anyway. And that's why, for instance, fread also accepts like a void star, right? So I think because of that, read buffer or panic should also accept void star, so we can avoid the warnings in here. Okay, so png.c does not appear to be the valid format, and let's take a look at the PNG transparency. And here is the interesting thing. So here is the chunk size, and if we assume that the chunk size is in bytes, right, which does make sense. So this thing has to be 128, basically this amount of kilobytes, and this amount of megabytes, right? So it's saying that the size of the image is, well, at least one chunk, we're not talking about the image, one chunk is 208 megabytes, and this is because of the wrong order of the bytes, right? And the size of this thing is actually like magnitude smaller, it's 222 kilobytes. So to make it correct, we essentially need to reverse the bytes, right? So let's go ahead and try to reverse them. Let me go ahead and do that. Maybe we can have some sort of a function called reverse bytes, because why not? Reverse bytes. You can print bytes, you can reverse bytes. Maybe because of that, this function should be called read bytes or panic, right? Because you basically print bytes, reverse bytes, and so on and so forth. I think it makes sense for, you know, for the consistency, read bytes. There we go. So now we are reading bytes. Here we are reversing bytes. There we go. So how we're going to be reversing the bytes, we're basically going to be iterating from the beginning to the center, and then basically swapping the elements, reversing everything, you know, the usual trick. So I'm going up until buffer divided by 2, right? And essentially what I need to swap, I need to swap buffer I with buffer capacity minus I, and I think minus I is not enough, right? So if you have bytes 0, 1, 2, 3, 4, you in fact have 5 bytes, right? And if you have something like 0, and you take the amount of bytes and subtract 0, in reality you would get 5, which is not the last index in here. So essentially you have to do minus 1 to get 4. So you have to put minus 1 in here. So this is 2 bytes that you have to swap. let's go ahead and just save this entire thing into separate variable. Once you save this thing in a separate variable, you can quite safely just reassign it like so, and then you restore this entire thing from the temporary variable. Alright, so it should be roughly like this. This is how we're going to be reversing the bytes. Okay, so we read bytes or panicked, then we reverse the bytes. For the chunk size, size of chunk as z, and then we basically print that value, right? So let's go ahead and just see what is going to be printed. And yet again, it's kind of the same situation. This thing has to be void, right? This thing has to be void. Oh, okay. All right. So it means I need to have like an extra binding that converts this void to uint8. And how should I call this thing? Right, because I already have buffer. Let's call it buffer 0. I don't know, right? Because we kind of don't have any choice, right? So it's dumb. It's dumb that I have to do that, but that's what I have to do. So the size of the chunk now is 13, which makes way more sense in my opinion, right? It makes way more sense. But this size does not include the type of the chunk and the redundancy check, right? So if I understood correctly, let me try to draw this entire thing. Where is my tablet? Here's the tablet. So ignore for now. Can I just cancel this entire thing? Can I cancel it? Recover and save. I don't know. I just want to ignore it forever, not for now. Nice UX, by the way. Thank you so much. Anyway, so here we have the size, right? So this is the size. Then what do we have? Where is that thing? We have the type, right? Here is the type. Then we have the data, right? And if I understood correctly, the size is the size of this data, right? It doesn't include the type, neither it does include CRC, which is like a checksum for the data, I presume. So to get the data, we need to read another 4 bytes, right? I think we need to read another 4 bytes. So let's go ahead and do that maybe. So, and type is a 4-byte chunk type code. For convenience in description and in examining PNG files, type codes are restricted to consist of uppercase and lowercase ASCII letters. Oh, okay, it's not even a number, it's ASCII letters. However, encoders and decoders must treat the codes as fixed binary values, not character strings. For example, it would not correct to represent the type code IDAT by ABCDE equivalent of these letters. Oh, I see. No, I don't see. Anyway, additional naming conventions for type chunks are discussed in the next section. It's really strange, but we can try to just read it as, you know, 4 bytes or whatnot. So this is the chunk size. Type chunk type. It's gonna be 4. Read bytes or panic. Input file chunk type. Size of chunk type. Right, there we go. And then we can print the bytes. Chunk type. Size of chunk type. There we go. So it's 4 bytes. And they do fall, I think they do fall within the range of ASCII, aren't they? I think they do. It's very interesting. So if I take a look at 73, it's I. What about 72? But it's a different one. God damn it, it's not particularly convenient. IH, so it probably spells IHDR. Okay, so let's actually try to print it as the string or whatnot. It's going to be printf. If I remember correctly, it's something like .*s, and we say that we have a size of chunk type and the chunk type itself, and maybe we can do something like chunk type, Right, so let's take a look at the chunk type. Okay, so it spells out a HDR, so it's like 4 bytes, but they spell out these characters, right? But you have to treat them as the number, as the like 32-bit number. Oh yeah, and there is a very interesting thing is that according to the C standard, I suppose this thing has to be an integer. Alright, so I have to explicitly convert it to an integer, which is kind of weird, but I know exactly the size of this buffer, right? I know that it's going to fit into the integer, so I think I'm fine with that. So here is the chunk type. So the next thing, we probably want to skip the chunk for now. I don't really want to go inside of the chunk. I just want to skip the chunk and try to read the next chunk, if you know what I mean. Right, so yesu. So I'm just looking for interesting questions in the chat, maybe. Hello everyone. Is there a good online source for the file format? I think the best online source for the file format is its specification on the official website libpng.org. Is that official? I think the creators of libpng are also creators of the PNG format. I think this is the best resource you can get, right, from the creators of libpng. So I recommend to check it out in here. So yeah, it's basically like describes the format, but surprisingly it describes it in a very approachable way, not like in RFC way, right? So you can just read like this file structure section and get an idea of how the PNG file is organized, which is kind of nice. So I'm just looking for any other interesting questions. Are you doing it in STB style? STB style is applicable to libraries. But I'm not writing a library, I'm writing an application, a throwaway application to explore the format itself, right? So when you're writing a code, when you're writing a program in any language, it doesn't mean, quite rarely it means that you're writing a finished product that you will have to deploy to the server or deliver to the user. Quite often what you're doing, you're just exploring things, right? There's no a particular tool that allows me to explore the bytes of a file with this much precision and this much control. Yes, I could have just taken some sort of like a hex editor and just look at the things byte by byte. But here I'm using C programming language as the tool of exploring bytes because I have a Turing-complete programming language where I can allocate some memory, I can write some bytes in one format and other bytes in a different format. I can also have a logic that traverses those bytes, and depending on different things, it can do different things. And it's not kind of possible to do in a hex editor, right? So I'm using C as a programmable hex editor. Does that make any sense? Because like not everything you write is a finished product that you deliver to the user. For instance, here I'm using C as a hex editor, which is actually a very powerful tool, by the way. C programming language is a very powerful hex editor. Does it make sense? I think it does make sense. All right, so I think we ran out of interesting questions, so let's continue programming. You know what? I think I want to make a cup of tea, right? Before I continue just like slapping more code and maybe like reading the chunk data and also reading CRC, I really want to make a small break and like, you know, make a cup of tea because I didn't make a cup of tea before the stream. I only had water. All right, so let's make some break and all right, so the next thing we need to do, we need to read the chunk, but I want to read several chunks, and they probably going to be in a variable size, right? They're going to be in a variable size, so I need a way to skip the chunk. So I think the easiest way to skip the chunk is using something like fseek, right, which allows you to set the cursor. So I wonder if there is any way to specify a relative offset for the cursor, right? So there's several things you can use in here, like in whence, to set the cursor in absolute way, and seek cur, I don't know what it is, and seek end sets basically at the end. So the offset is relative to the start of the file, the current position. So this is basically the relative offset. This is probably what we need in here. Or end of the file respectively. Okay, that's actually pretty cool. So I can straight up just use fseek to skip the chunk, right? So it's going to be fseek. Let me even copy paste this entire stuff. Fseek. Why can't I just jump there? Why is it so hard to just jump to things? Input. File path. So the offset is going to be literally the chunk size, right? So this is the chunk size, and the whence is going to be seek cursor, because it's relative to the cursor. If this entire thing fails, we can say that we couldn't skip the chunk. fprintf stt error error could not skip a chunk, right? Could not skip a chunk. Because of the reasons, and we can even print the reasons. So how can I print str error no, right, and then I'm gonna exit with non-zero exit code. There we go. So after that we should expect the checksum, right? We're gonna store it in int32, I think. So is the checksum 8 bytes? Yeah, it's also 4 bytes. It's actually 4 bytes. Chunk crc, we're gonna read the bytes or panic. We're gonna read that from the file input. Chunk crc, so here is the pointer, and then the size of chunk crc. I don't know if we have to like reverse that or not reverse that, because it probably doesn't even matter, because the control sum is probably just 4 bytes. So yeah, for now I'm gonna just print it as the hexadecimal value. It's gonna be chunk crc. Let's put it this way. So it's gonna be x, and I'm gonna prefix it with 0x, and I wanna pad it to 4 characters, right? No, 4 characters, 8 characters, 0, 8. I think that's the way we're gonna do that. Chunk crc. Okay, so essentially we read the first chunk, input file. So this is just the input file, and there we go. So here is basically chunk size. So the size of the chunk is 13, the chunk type, and the chunk crc, which is pretty cool, isn't it? I think that's pretty cool. So there's no new thing in here, new line in here. I want to kind of like format everything a bit nicer. I think I'm gonna move the printing after we like read the whole chunk. So here's the code that essentially reads the whole chunk, and in here I can just like format things a bit nicer, just a tiny bit nicer. Yeah, there we go. So this chunk size, type, and so on and so forth. So the whatever we print at the beginning is in fact a signature, right? So maybe I want to even do something like this. Signature, like so. So this is the signature, and this is the chunk. So let's actually try to maybe read more chunks. What if we read like several of them? What if we read 2 chunks? We can actually do that somewhere in the loop, but the question is, when do we stop the loop? But do we need to stop it if you think about that? Because we have things like read byte or panic, and essentially if you try to read more, it will just crash the application, right? So let's just like basically read while true, right? And just like keep reading the chunks until we crash. I think we can afford that. So if I try to do something like this, that's very interesting, right? So couldn't read PNG here. Oh, okay. So we kind of like copy pasted the error message, right? And now the function read byte or panic just says something about PNG header, but now we're using it not only for the PNG header, right? So we should probably like change it. Could not read something like ZU bytes from file. I think that's fine. And then we'll have to specify the like how many bytes we were trying to read. So this is going to be the buffer capacity, and this one is also going to be the buffer capacity. There we go. So if I try to do something like that, I forgot the comma. Okay, so there we go. So here are the chunks, and apparently we have 3 of them, but it's kind of difficult to read. What if we separate them with lines, right? So with bars, like so. Print. There we go. So we have 3 chunks in here. We have 3 chunks. The first chunk is iHeader, I presume. The second one is iData, which is 226 kilobytes, which is like looks like true. Right, because here we have 222, but this is because probably this is KB bytes, right? If we take this entire thing and divide this thing by 124, I'm pretty sure it's going to be 222. Well, it's close, and then it got rounded up from half in here, and it became like 222 essentially in the ls command. I think this is basically what happened in here. But yeah, that's pretty cool. But it's kind of lame that essentially we just iterate the entire thing until it crashes, right? So it would be nice if we stopped, for instance, when we encountered iEnd. That would be kind of cool. And also, here's an interesting thing. You have to treat types as like numbers. What if on top of printing the chunk as characters, we could print it here as a number, so we can use that number in logic to stop reading the PNG files and whatnot. You know what I mean? I think that would be interesting. So here is the type, and somewhere here in parentheses we can do something like this, 08x, and then we take the chunk type, right? We take the chunk type, and now we need to interpret it as the 32-bit integer, right? So we have to use some sort of like a type punning. We're gonna cast it to a pointer to 32-bit integer, and then we're gonna dereference it, right? And that will give us the actual value that we can use in here, right? So there we go. So here's the value that we need. I think that's the value that we need. And if you never heard about type punning, I really recommend to Google it up, because it's a very important technique in low-level software development. Right, so check it out. I'm gonna copy-paste it in the chat. You can find it in here, and then I'm also gonna put it in the description. Type punning. There we go. So, and now what I can do, I can just grab this value, right? And then after we read the type, right? After we read the type, I can just check that this entire thing, when casted to uint32 and then dereferenced, is equal to that, and we can do something like quit equal true. So we can have some sort of a variable in here, right? So it's going to be boolean quit false, while not quit, just keep doing the entire thing. Just keep doing that. And I think for that entire thing to work, we have to include std boolean, right? We have to include std boolean. All right, so what do we have in here? So this is something like that. Cool. So as you can see, once we encountered the iEnd header, we stopped the entire reading process, which is very freaking interesting. Right, that means if I add some garbage at the end of the file, that is not going to affect the readability of the PNG image, right? So I can just try to read it again, and as you can see, it just knows when to end, right? But at the end of this entire thing, we have some garbage that we put in here. So let's actually put something interesting, like Zosi was here, right? So we can put Zosi was here, and everything's fine. And what's interesting is that I still can open, because I would presume that a lot of viewers probably also don't care what's after the I-end header, I-end chunk, right? So yeah, I think that's very interesting. So this is one way to maybe hide something in the PNG image, right? But it would be interesting to hide something within the chunk, right? It would be kind of interesting to hide something within the chunk itself. And as far as I know, there are the text chunks, and also, if I remember correctly, if the viewer or a parser encounters the chunk that they do not recognize, they are allowed to basically skip that chunk. So that means we can create our custom chunks with our custom format, and all of the software will just ignore that chunk. So that way we're not going to have any obvious data at the end of the file, right? Because if somebody knows like how PNG works, they will look at the end of the file. We can have a hidden data in the middle of the file in some sort of like a custom chunk that a majority of the software just ignores because they do not recognize that type of chunk. So this is a little bit more interesting than just putting something at the end. What do you guys think? So yeah, I think that's pretty cool. So here I have my tea, by the way. I have a new teapot, so I'm gonna just pour a cup of tea. Tea pog. Cheers, by the way. So let me take a look at the chat. Maybe somebody asked interesting questions. Polyglot files. Yeah, polyglot files is an interesting topic, by the way. Yes, it's basically files that I suppose can be recognized as different formats by different software, right? In like all in one. It's an interesting concept. I also like an idea of polyglot programs, right? When you have a source code that can be recognized by several different interpreters and compilers as a correct, valid program in that language. So there's such concept as polyglot programs. I really want to explore that concept because it's very, very interesting. Polyglot programs. It is in fact a very interesting concept. Is a computer program or script written in a valid form of multiple programming languages which perform the same operation or output independent of the programming language used to compile or interpret it? Yeah, there we go. I suppose this is a both valid PHP and C program, which is freaking terrifying. This is a terrifying piece of software. Like, you can threaten people with this thing. So yeah, holy fucking shit. Anyway, so I'm gonna quickly paste this thing in the chat for anyone who's interested, and also I'm gonna put that in the description for anyone who's watching live. Polyglot program. Just Lucy, thank you so much for 6 months of tier 1 subscription. Thank you, thank you, thank you. And welcome to our epic PNG club. How about that? I wonder if it's possible to hide the parser inside of PNG. Probably. That's an interesting idea. So essentially to have a polyglot file that can be recognized as both PNG or ELF file, right? And then if you try to interpret it as an ELF file, it will try to parse itself and produce an image. But here's an interesting thing. All of these formats, they have the signature at the beginning, right? So the signature at the beginning, which means once that signature is different, it is not recognized as a valid format of that, as a valid format at all. So I don't know how to circumvent that. So, yesu. Recursive PNG. Recursive PNG is also an interesting idea. So basically you have a chunk that itself is a valid PNG format. That's a very interesting idea. It will be also interesting to explore that. Yeah. All right, so maybe it's possible with zip and maybe some window PE thing, since that has the header at the end. Oh, that's very interesting. I didn't know that. All right, so let me continue. So what's going to be the next thing? We read this stuff. And I want to kind of maybe inject some header in there. But the question is, where can I inject a header? I can try to inject a header after iHeader. But let me try to see. So let's create a function. Inject custom chunk. Right, inject custom chunk. And we're gonna accept the file where we output this entire thing. Right, so this is gonna be the file, the output file, and then we're gonna provide the data. Right, so we're gonna provide the data, buffer 0, then size t, buffer capacity. Buffer capacity. So, and in here, I suppose we're gonna just do the reverse thing. We're going to print the size of the chunk, because we know the size of the chunk, by the way. Then we're gonna print the type, but we'll have to accept the type, right? So we'll have to accept the type. So we're gonna put it like this. Right before you're gonna type me, but Zozin, did you know that you cannot pass arrays in a C by a value? I'm gonna tell you, yes, I do know that, but I still write it like that for documentation purposes. Okay, so I do know C to that level. I'm not proficient in C, but I do know that you cannot pass arrays by values. I do that purely for documentation reasons. Okay, so this is the buffer, this is the chunk type, and then we'll have to calculate the CRC. And this is a very interesting part. I think I need to learn how to calculate the CRC. Or maybe I shouldn't. Let me try to inject a chunk with incorrect CRC and see if any of the software will complain about that. Maybe majority of the viewers just ignore the entire thing, right? Who knows? We'll see, we'll see. So let's do the following thing. So we need to print the size of the chunk. But this one is very interesting because I need to do something like uint32 chunk size. So here's the chunk size, and I basically need to cast the entire thing to 32-bit. But then I have to reverse the bytes, but I do have a reverse bytes function in here. So I can do chunk size and then size of chunk size. So I have a reversed bytes in here, which is rather convenient. And then I can print those bytes into the file. So we're going to use fwrite for that. We're going to use fwrite. So here I'm going to provide buff0. So I think I don't need to actually call it buff0 because I don't need to access the individual bytes, at least for now. So the size of this thing is the buff capacity, and the amount of buffers I write is 1, right? And then I write all of that into a file. So, and then I expect that fwrite returns 1, right? If n equal 1 does not equal to 1. Okay, if it does not equal to 1, we have to check several things. I suppose fwrite suffers from the same error madness as fread. So return the number of items read or written, the number equals. Fread does not distinguish between end of file and error. I suppose fwrite does distinguish. If an error occurs or the end of file is reached, the return value is a short item count or 0. So I guess in the case of fwrite, end of file may never happen. So we can just check something like this: if ferror file we're gonna say something like std error could not write this bytes to file because of reasons. Then we're gonna say buff capacity, str error, error no, and then we're gonna exit with non-zero exit code. There we go. Otherwise, here we have unreachable situation. We're gonna do assert unreachable. Cool. At least for now. Maybe it's gonna change in the future, I don't know. So here we wrote a thing, which leads me to a very interesting idea. I think we should have a similar function that writes bytes into a file, right? So we have read bytes or panic. We can have something like write bytes or panic. Write bytes or panic. Okay. I'm gonna put it like that. If I go back, so here I will just do write bytes or panic file, and then I can just put it like this. Okay. Now let me try to compile that. This is the buffer, so I suppose the signature is going to be literally the same as in read, right? And what else? We have some warnings in here that, oh, inject custom chunk is not finished yet, but that's fine. Okay, so we wrote the chunk size. Now we need to write the type. So we're gonna do write bytes or panic, and we're writing the chunk type, right? So we're writing the chunk type, and we know that the size of the chunk type is 4. So then we need to write some data into this thing. But the question is how, like, what kind of data can we write in there? So let's maybe put something like write sister or panic, right? Because that will make it super easy for us to just say file hello world, right? File hello world, and that will just basically insert. Oh, wait a second, I'm providing the buffer. Okay, I'm sorry. So I can just do write bytes or panic, and I can just provide the buffer. I forgot that I have a buffer in here. Okay, so the next thing we want to have, we want to provide the CRC. uint32 chunk CRC, and for now I'm gonna just put it as 0 and see if, for example, Fer or browser will complain about like invalid CRC somehow, because I think it's kind of interesting. So it's like a part of the exploration. Maybe software don't like care about this thing at all. I would presume that browsers care, but maybe something like Fer, which is like a client side, maybe they do not care. Who knows? But maybe they do. They're probably using some sort of libraries anyway, and the libraries just probably check this thing by default, so all the software that uses those libraries check it. And I think I even know what libraries they probably use. They probably use libpng, and since I think libpng are the creators of the PNG format, they probably check CRC. So yeah, I think majority of the software does care about CRC because they use this library. I think that makes sense. That makes a lot of sense, actually. Anyways, so let me recompile the entire thing, and everything is compiled. But now I want to do the following thing. I want to open the second file, right? So we have an input file, but I also want to have an output file into which we're going to be writing the chunks. You see? We're going to be writing chunks in there. So let's update this entire thing. Output PNG, right? So now we're gonna accept two file paths. So I think it probably makes sense to actually introduce something like void usage char program, right? And move everything related to usage there, like so. And this one is going to be usage std error program, and I think this one has to be something like file, right? And this is file. Cool. So the first thing we check that we have some input stuff, and if we do have input stuff, we just assign it there. Then we check it again, argv equal to null, Right, and this is where we couldn't find the output file. No output file is provided. And this is where we're going to put this entire thing. Output file path. Cool. So if I try to compile and run this entire thing, as you can see, it says that no output file is provided. Right. So now I have to do something like output PNG. Right, and now it works. So on top of opening input file, I think the other thing we want to do, we want to open the output file, right? So it's going to be fopen input file path, and we're going to open it for writing. And if we couldn't do that, we have to say that we couldn't open that file. Print f std error error could not open file s. Because of this reason, right? Because of this reason. Output file path, str error, error null, right? And then it's going to be exit 1. All right. So what do we have in here? Could not read, reach the end of the file, which is rather interesting because I used incorrect variable in here. So what the hell? Because I'm supposed to be opening this thing for writing. So output file path, output file equal to null. If it's equal to null, we say that we couldn't open that, and that is fine. So I literally don't see an error in here. So what the hell is going on? Is that because... Wait a freaking second. Am I going crazy? I feel like I'm going crazy, like holy shit. So this is the input, this is the output, and could not read 8 bytes from file, reached the end of the file. So let me do the following thing. I'm gonna just print this entire stuff, right? Input s, input file path, and then the output. It's probably something very dumb. I'm pretty sure about that. And you probably already noticed that, but I didn't read the chat, so you have to suffer. Okay, so here is the input and here is the output. Okay, that's cool. I really don't see that. Am I going crazy? Because now it works. And it also destroyed that thing. Ah, I see. Oh, okay, so probably my previous attempts destroyed the original file, so now it is incorrect. Okay, that's fine, so I can easily just like restore that thing because I'm using Git. Alright, that's pretty cool. So it is correct, it's just like my previous incorrect code destroyed the file. That's kind of the point. Alright, so, okay, that makes sense, sure. And if I try to do that, it still works. Okay, that explains everything, cool. Now, when I read the whole thing, right, I want to basically transfer the chunk into, I guess, into the output, right? I guess I want to transfer it into the output. But the question is like, so do I want to also copy CRC? I think I do. I think I'm going to accept CRC as a parameter here as well. I think that's a pretty good idea. So it's going to be uint 32 chunk CRC, and we're going to get rid of this entire thing. That way, I'll be able to sort of like pass the chunk that we read, from. This is not going to be particularly convenient. This is not going to be particularly convenient because now we need to think how we can read the whole chunk, right? So we can read the size of the chunk, then we can pre-allocate the buffer into which we're going to read the whole data of the chunk, and then write it back into the output file. But it's not particularly convenient because who knows like how much data this thing will tell you to allocate, right? It's kind of dangerous. Like imagine the file format, the number in the file format actually controlling how much you malloc And what if they put like a huge number, like the maximum number of 32-bit number, and you'll basically allocate 4 gigabytes, right? So, and it's kind of like, nah, I didn't think it's a good idea. So I think the way I want to manage the memory in that case is that I want to pre-allocate a fixed buffer, right? And copy the input file like chunk by chunk, right? So I can split the data of the chunk into chunks, right? So that's what I want to do. That's essentially what I want to do. And yeah. So maybe because of that, this function is kind of useless, because I started to design this function way too ahead because I didn't really know what I want. So I think I'm gonna get rid of this function and just continue like piling code on top of this thing until like a reasonable pattern that I can, you know, factor out emerges, right? Because that function is not particularly useful. Anyways, so here we read a bunch of bytes, and here is the size, and then we reverse the bytes and whatnot. Though we can try to do something like write bytes or panic, and we're writing them into the output file, chunk size, and there we go. So something like this. Cool. So as you can see, we're reading something and we're writing it right away into the output file. The next thing we need to do the same thing for the type. So this is going to be output file, chunk type. Okay. So if it's the end chunk, we'll exit at the end of the iteration. So, and here we're starting skipping the chunk, right? We're basically skipping it. But I don't think this is what we want to do. Right. So let me allocate some sort of a buffer chunk. Some sort of a buffer for the chunk. Chunk buffer capacity. So, and let's allocate like 32 kilobytes for a single like chunk or whatnot. And in here we're gonna have something like this, chunk buffer. Right, so this is a chunk buffer and this is a chunk buffer capacity. And this is where we're gonna just read everything, right? So after that, after we got the size of the chunk, we want to kind of get rid of this thing, right? Maybe I'm gonna temporarily just like put 0 in here, else, and if. All right, and in here we're gonna do the following stuff. We probably want to have like some sort of a variable that keeps track of how much we already sort of like copy it. So let's have chunk. So we already have chunk size, unfortunately. N already exists. Okay, so this is going to be chunk size, and while n is greater than 0, the thing we're going to do in here, we're going to read. This one is also not particularly convenient, unfortunately. So f read. So this is going to be chunk buffer, and the size of the element of reading. So this way, this time we're going to be actually doing the opposite thing, right? In read bytes or panic, I'm reading one buffer of the size of the buffer, and I think here we're going to be doing the opposite thing, maybe, because we can read less, right? We can actually read less, but at the same time we know precisely the size of the buffer and how much we still have to read. So yeah, I think we could use read bytes or panic. I think we could. Essentially we can just figure it out. So I have n, but if that thing is greater than the capacity, the chunk buffer capacity, this thing will become the chunk buffer capacity, and this is precisely how much I need to read. And if I read less than that, that is an error, right? So we kind of know what to expect, even though we're reading chunk by chunk. Dr. Poopy, thank you so much for 9 months of Twitch Prime subscription. Thank you, thank you, thank you, and welcome to our Epic C Club. Thank you, thank you, thank you. Epic, absolutely epic. Okay, so and because of that, right, I can right away maybe subtract this thing. So this is going to be n, or maybe not. Right, we can actually put it in here. Right, if m is greater than this, and this is how we read, and this is how we match subtract, and so on and so forth. After that, I can say read bytes or panic, and I can read it from the input file into the chunk buffer, right, into the chunk buffer with m. Right, and I know that I have to read precisely m, and if I read less, that's a bug. That's a problem, right? It's not a bug, it's a problem. And after that, I can just like write bytes or panic into output file, chunk buffer m. Okay, and that way I essentially copy in everything. Okay, that's cool. Okay, I like that. So, and in here, we are basically copying the CRC. So we're going to write bytes or panic into the output file, and that is basically it. Right. So essentially what we're doing, we're just copying one file into another one, chunk by chunk, but that will allow us in the future to inject new chunks in there, if you know what I mean, right? So that will allow us to do more interesting things. Okay. So, and did it copy it? I think it didn't. And I think I know why. This is because I forgot to close the output file. And it still didn't do anything. Alright, so we made a mistake somewhere. Output file, so we're reading the chunks and we're writing it. Oh, because I actually never... Okay, I see. I have to enable that thing. Could not read from file, reached the end of the file. That is very interesting. Why couldn't you? Why couldn't you do that? That is very, very interesting. Another interesting question is where exactly that thing has happened. You know what I mean? That is another interesting question. Like, which of these things actually failed? And I think I know a way to tell us, right? So you can always just pass something like file, source file, and a line, source line, as a parameter, right? And every time you call this thing, for instance, like this, it's kind of close. Oh, and another thing I forgot to copy is actually signature, right? So I noticed that. But anyway, besides the point. So, and then you can do something like file and the line, and then we can use the source file and source line in error reporting in here, like so. So we can do something like S, D, and here we'll have to do source file, source line, right. So I think this is particularly convenient. So it will tell us precisely where this shit has happened. But it's not particularly convenient to do all of that manually all the time, right? Because like it's kind of nah. One trick we can do, we can rename this entire thing to like underscore, and then have a macro, read bytes or panic. It will accept buffer, file, buffer capacity, and then it's gonna call the underlying thing like so, right? Provide the file, buffer capacity, and then automatically file and line for you. You don't even have to change any of the existing code. The code will have the location of itself automatically just because of this stuff. And we could do a similar thing for write bytes or panic. We can literally do the same thing. So let me see. So might as well just copy paste this stuff. 21. Just a second. So this is source file, error, S, D. Mutamam, thank you so much for Twitch Prime subscription. Thank you, and welcome to our epic C Club. Proud of you. You're now a proud member of C Club. Does it feel good to be a member of the C Club? I think it does. So in here we do write bytes or panic, right? So here's a write bytes or panic, write bytes or panic. Wait, I can see something fishy in here. All right. I hope I didn't make any stupid fucking mistakes, man. All right. So if I try to compile the entire thing, and now it tells me where exactly that happened, and it happened in here, as you can see, which is very fucking convenient, right? So it just tells me that this shit happened here. And this is in a language without exceptions, stack traces, or anything like that, by the way. Speaking of... all right, so what do we have in here? Why would it fail? Because... we can... It also tells us how much, right? It also tells us how much. Oh, I see. Because I'm supposed to subtracting m instead of these chunks, so something definitely went wrong in here. Let me try to do that, and there we go. It managed to actually work correctly, but it didn't copy it correctly anyway. This is not the correct image because we forgot to copy the signature as well, right? So we have IHDR, but as you can see in here, we don't have the PNG header, right? So we have to copy it as well. So let's go ahead and do that. So where do we accept the PNG header? So read, write, bytes or panic, the output file, and let's do that one more time. And this is a correct PNG image. Copy it, you know, chunk by chunk, chunk by chunk. Okay, chunk by chunk. Right, I'm just looking at the chat. Maybe somebody asked any questions, any interesting on-topic question. So people say there is some sort of like static noise or inference. Can you hear that right now? Is the sound okay right now? It's okay. 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 Thank you. Thank you so much. Input file got truncated. Thank you. I know that. All right. Cool. So let's continue. So what we want to do in here, we want to try to inject a new chunk. So I think we should not skip the chunks anymore, if that makes any sense, right? So let's actually not skip the chunks. Let's just like keep it in here. Right. So that's pretty cool. This way, as you can see, the file format, the file data does not influence how much memory we allocate. We just pre-allocated 32 kilobytes of memory, right? And that's it. No matter how big the chunk is, we're not going to use more than this amount of memory, right? So there is a very weird style of C programming that I absolutely despise, and that style is basically people mallocing shit like crazy and trying to keep track of like where to free that. They have a lot of like ifs, else's that, okay, if that's an error, you have to do like free and that and that and that. And I certainly program in that style, and that makes the experience programming in C absolutely horrible. It's like, this is like a primary reason why C has a bad reputation, because everyone just assumes that this is how you have to program in C. In reality, you can program in C differently, with as few mallocs and frees as possible, and it actually makes your life way easier. It's just like, I don't know who thought that this kind of style of like crazy mallocing and crazy freeing is a good idea, but somehow it's just like there's a lot of software written in that style. And by the way, that software is extremely vulnerable. A lot of like vulnerabilities that people find in C software is just, it's written in that style, in that horrible, horrible style. Anyway, so that style comes from the idea of, you know, thinking that you have a lot of small objects with individual lifetimes, when in reality you have like a few lifetimes and a lot of objects that just fall in one of the existing lifetimes, but whatever. So let's continue. Yeah, I want to basically inject something sort of in the middle, but maybe not in the middle. How about at the end? Right, so let's go ahead and somewhere here do the following thing. We copy the chunk at this point, and let's take a look at the type of the chunk. If the chunk was header, let's quickly inject another chunk that's probably unknown by the majority of the software. So let's try to do that. But to do that, I need to know the value of that header. Okay, so essentially what I can do now, I can just take this thing, and if chunk type is equal to this, right, so it's going to be uint32, I'm going to do it like that and dereference this entire thing. We are injecting a completely new chunk, right? And this is where the inject chunk function would be actually very useful. So I think I need to bring it back. Right. So what I want to do in here, I want to do inject chunk, and I need to specify the size of the chunk first. Right. Maybe not. So let's actually don't introduce any functions. Let's just write as this. So the first thing we want to do, we want to specify the size of the chunk. It's going to be uint32t injected size. And what's going to be the injected size? Let's say that the injected size is going to be 13, because that's the size of hello world, right? I think. Is it? It's actually 12. 13 is for new line. Okay, so this is going to be 12. So this is the injected size. Then we need to have an injected type, right? Somehow. And the question is, how can we have that? So what's going to be the injected type? This is supposed to be 4 characters, right? So, okay, let's call the type of the chunk cock. Maybe like that. So they can be like in different, you know, capitalization. And as far as I know, capitalization indicates essentially some sort of like bit set or not. So yeah, let's actually use this thing. So this is going to be inject. We're injecting cock into the... What the fuck is wrong with it? Okay, so let's actually call something different. I'm not going to go that far. So it's funny. Okay, so we're injecting cock into PNG. So right. How do you spell that? Injected type. Right, so this is going to be injected type. Now, so let's go ahead and do that. I'm going to do write bytes or panic output file, injected size of injected size. Injected size. All right. So then I'm going to be providing the injected type, injected type, and this one is going to be 4, right? So this is basically 4. I know that for a fact. Then I need to write the data, right? So output file. Oh, you know what? I think I know what I'm going to type in there. So the size is going to be 3. So the size is 3. And the data that we're putting in there is going to be yep. And injected size is going to be that. And the last thing we need to provide is CRC, right? And as I already said, we can put like a invalid CRC in there just to see how the software will react to that. Injected CRC is going to be 0. So injected CRC, it's like that. Size of injected CRC. Okay, so that's cool. Let me see. So is it bigger? Can I just like take a look at the sizes in here just to see if the output is bigger? I think the output is a little bit bigger because it's like 48. And if I take this entire thing and essentially just put it in here, right, and then 33, it is 15, right, which is maybe correct because that's the size of the whole thing. Right, you have essentially 4 bytes for the For the length, 4 bytes for the type, then 3 bytes for the actual data and 4 bytes for this thing, and it's exactly 15. Okay, that makes sense. That makes a lot of sense. So now I can go ahead and open, and it is incorrect. Look at that. This is very interesting. So here we have this thing, but I think it screws up the library that we're using. So it is not considered to be a valid thing. That is very interesting. Okay, so we can try to calculate the correct CRC then. It needs to be C. Oh, yeah. I remember that capitalization is kind of important. But I don't remember what capitalization actually means. Right, I don't quite remember. So let me see. It doesn't really change anything in here. Let me take a look. So chunk type, chunk naming. Okay. Chunk type codes are assigned so that the decoder can determine some properties of a chunk even when it does not recognize the type chunk. These rules are intended to allow safe, flexible extension of the PNG format by allowing the decoder to decide what to do when it encounters an unknown chunk. The naming rules are not normally of interest when the decoder does recognize the chunk type. 4 bits of the type code, namely bit 5, value 32 of each byte, are used to convey chunk properties. This choice means that a human can read over the assigned properties according to whether each letter of the type code is uppercase, bit 5 is 0, or lowercase, bit 5 is 1. So this is actually kind of genius. Essentially, the type stores not only the type of the chunk, but also some of the bits set within that chunk. And depending on whether one of the 4 bits is set, the character of the corresponding bit is going to be either a lowercase or uppercase. This is kind of genius. I really like that idea. So it's actually pretty cool. So Nate Lift 151, thank you so much for 2 months of tier 3 subscription. Thank you. Actually 3 months of tier 3 subscription. Really appreciate it. Okay, so so namely bit 5 to each uppercase. So uppercase means that the bit is 0 and lowercase means that the bit is 1. Okay. It is worth noting that the property bits are an inherent part of the chunk name and hence are fixed for any chunk type. Thus blop and blop would be unrelated chunk type codes, not the same chunk with different properties. Decoders must recognize type codes by a simple 4-byte literal comparison. It is incorrect to perform case conversion on type codes. Okay. The semantic of the properties bits are ancillary bit. Okay. Bit 5 of the first byte. Critical, ancillary. Okay, so that means the first thing probably has to be small, because it's not very critical. Right, C is basically not critical, I'm pretty sure. Are not strictly necessary in order to meaningfully display the content of the file are known as ancillary chunks. A decoder encounter an unknown chunk in which an ancillary bit is 1 can safely ignore the chunk and proceed to display the image. The type chunk time is an example of ancillary chunk. Chunks that are necessary for successful display of the file content are called critical chunks. A decoder encountering an unknown chunk in which the ancillary bit is 0 must indicate to the user that the image contains information it cannot safely interpret. The image header chunk IHDR is an example of critical chunk. Okay. Cool. A public chunk is one that is part of the PNG specification or is registered in the list. Okay. Lowercase, uppercase, public. Okay, so I can see why you need to set these two things to like lowercase, right? Because this is a private chunk and this is ancillary, so you may basically safely ignore all that. So reserved bit must be 0, uppercase. Okay, so this one is uppercase. Save to copy bit. This property bit is not of an interest to periodic decoders, but it is needed by PNG editors. This bit defines the property handling of an unrecognized chunk. So save to copy, unsave to copy. I don't know. Maybe I want to set it to 1, right? So what the fuck is going on? There you go. So I think this is basically 1, but we can actually keep it like that. Okay, whatever. So I presume that now everything is okay, right? And the only problem that we encounter in here is essentially the CRC problem. So let me take a look. CRC, I know that there is some algorithm here. Chunk CRCs are calculated using the standard CRC method with pre and post condition as defined by ISO, blah, blah, blah. The CRC polynomial employs this. Practical calculation of CRC always employs a precalculation tuple to greatly accelerate the computation. See sample CRC code, right? The following sample code represents the practical implementation of CRC employed by in PNG chunks. Can I just copy paste the entire thing? I feel like that I could probably copy paste it. Right, so let's go ahead and do that. I'm gonna just grab the entire thing and just violently, very violently, copy paste it in here. Okay. So basically I can also give the credit in here. Right. Stolen from here. Let me try to compile the entire thing, and it seems to be compiling. And we probably also need to call this function at the beginning of the program, right? So this is one of the things that we probably want to do. Okay, cool. And then, as far as I can see, you can just use CRC for the buffer and the length, and it will compute that CRC for you. So let's see if it's true or not. Let me see. This one is, yep, and the length in here is injected size, right, and here is an injected CRC. Okay, something went wrong in here. This is probably because pointer targets differ. Let me see. Why do they differ? It's an unsigned character. Unsigned character, but it doesn't really matter in the grand scheme of things, right? It's just like, yeah, probably doesn't matter. Anyway, so let me try to open this thing, and it still doesn't work, surprisingly. Surprisingly, it still doesn't work. So here's the cock. So I presume this is the... Did I reverse the bytes? Wait a second. I didn't reverse the bytes when I provided the size. I think that's basically what happened. Let's reverse the bytes. Reverse bytes, and I'm gonna just take this thing, injected size, and size of injected size, right? So then I put it in here, and everything seems to be okay, but I'm not sure about CRC. And then we have a segmentation fault. Nice. Ah, shit. Fuck. Damn. So I need to reverse it only for printing, but then I need to reverse it back. Endianness. Always fun. Endianness is always fun. Okay. So here is the injected type, and I suppose I can put it like that. So this is the injected size, injected type. So here's the type, then injected CRC, though I'm thinking that I'm gonna put this thing in here, right? So this is injected. Yeah, let's put it this way. Okay. So everything looks fine, and if I open this stuff, it works. But at the same time, we have injected a cock in there, and nobody knows. Nobody knows. So it is located in a private chunk that majority of the software will just ignore. How about it? Coke, yep. Yes, so that's pretty cool. And maybe, by the way, maybe it was all incorrect because I was not using big endian. And maybe because of that, we don't need CRC. Let's actually set CRC to 0. Is CRC really that important? Right, is it really that important? That's a very interesting question. Okay, so there's no CRC, and I'm opening this thing. Still correct. This mother flipper just ignored CRC. Just ignored it. And interesting question. What if I try to open that in Chromium? So I suppose when the chunk is supposed to be ignored, majority of the things will just ignore CRC, right? So because who fucking cares? Yeah, very interesting. Though, let's do the following thing. What if I go further? What if I go further? When I'm copying the CRC, what if I set the CRC of any chunk to 0? How about that? It's just like when we're copying things, let's just like erase the CRCs and all of them are going to be 0. Who cares? Right. So, and let's see if that affects things. Right, so we copy this entire stuff. Okay, that affects things. So that actually ruins the entire thing. And even the web browser is incapable of, representing that. So, yeah, so it's all 0. So you do need CRC for the chunks that are critical, I suppose. Right. But CRC of the chunks that are custom ones, quite often just ignored. All right, so we can do it like that, and here we have this entire stuff. Coke, yep. Okay, so let me do the following thing. I'm gonna actually keep all of that stuff in here. Git ignore, and we're gonna ignore output PNG. Output PNG. All right. So what we're gonna put in here? Implement the chunk injection. The chunk injection, and we're gonna push that right into the repo. You can find the source code of this entire thing in the description if you happen to watch on YouTube, or if you're watching live. I'm gonna copy paste the source code in here. I'm gonna copy paste this stuff in here. Very, very interesting. So I'm already streaming for 2 hours. I would like to continue, but I'm trying not to stream more than 2 hours because I get really overwhelmed. So I think I'm gonna finish today's stream right now. So I hope it was interesting. It was definitely interesting for me. It was super fun to actually write this entire stuff, like working with bytes and whatnot, and it's just like, injecting cocks into PNGs. Anyway, that's it for today, boys and girls. That's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you next time. I don't know when, I don't know where, but I definitely see you next time. Thank you for all of the subscriptions. Thank you for all of the beats. I really appreciate the support. And so let's maybe rate somebody. I don't know. Is anyone streaming anything super epic on the software development section of Twitch? Whoa. Epic. Do we have any epic cooders in the section? Jessica Mack. We already rated her multiple times, so I don't know. Let me see. So Rope Mark D. What did they do? What did they do? Software game development. But I wish I could see the Jai game development stream. Sounds like a good idea to actually rate the Jai developer. Jai is the sea of the future. Am I right? Isn't it? I don't know. We'll see. Okay, get ready for the raid, and I see you all next time. Love you all. Mwah.